Okay, so this is the worksheet, Bronsted-Lowry acids and bases. Let's see, can I go down? Okay. So make sure you've looked at your notes about definitions of Bronsted-Lowry acids and bases. It is another theory of acids and bases. It's not contradictory to Arrhenius. It's just another definition that's also considered to be true. So according to this theory, an acid is a proton donor and a base is a proton acceptor. Protons are H+. So I like to call this follow the protons. Okay? So for this example, H2O becomes OH-. What happened? Well, it must have given a proton to chlorine. Chlorine becomes HCl, which means it must have accepted. They just draw these arrows. That's one way of doing it, or you could just write acid, base, and then in the reverse, this is called the forward reaction, but this is called the reverse reaction. And you see we have a double-sided arrow, which means both of those reactions are happening simultaneously. So as H2O is giving to the chlorine ion, HCl is giving to the OH-, the hydroxide. So both of those are happening at the same time. So let's go ahead and try. Now, notice that both of these are water, so it really doesn't matter which one you choose to be acid or base because they're both water. So I'm going to just say this is going to go to here. So this is going to be our acid. This will be our base. Let's look in the reverse. H3O plus becomes H2O. How would H3O plus become H2O? Well, the only way is if it gave away an H+. So if it gives away, this must be our acid, this must be our base. I think the worksheet answer key says that this is the base and this is the acid. Remember, it doesn't matter because they're both water. All right, number 2. This is sulfuric acid and a hydroxide. Then we have sulfurous acid and water. Okay, H2SO4 is like our before. HSO4 minus is the after. What happened? I had 2 H's, now I have 1, which means it must have given it away, making this the acid. If this accepts, it has to be base. How do I know it accepted? Because it went from OH minus to H2O neutral. Now let's look in the reverse. HSO4 minus becomes H2. How could you go from 1 H to 2 H's? Guess I must have gained a proton from this. So H2O now only has 1 H. It gave it away. So this is our acid because we donate. This is our base. All right, let's try another one. HSO4 minus becomes SO4 2 minus. What happens? Looks like it gave away an H. So if it gives away an H, this is our acid, this is our base. Now, by the way, even though I see that all of these have gone the first reactant to the second, that doesn't necessarily have to be the case because you can write them in either order. So don't always say, oh, the first one donates to the second. It's not correct. H3SO4 goes to H2O. That looks like it gave away a proton to this. So this is also like that. Let me scooch it down a little bit. Okay. All right. OH minus becomes H2O. Which one? It doesn't matter. They're both water. So either way, hydroxide has gained a proton. And H3O plus has lost a proton to become H2O. So that means this gave to that. Acid, base. Now, in the answer key, it might be different than me. It doesn't matter. I'm just going to say this. I'm just going to call this the acid and this is the base. And of course, the answer key has it different, but that's all right. There's the same reactant. Finally, this last one, NH3 becomes NH4 plus. So we went from 3 H's to 4 H's. That means this must have gained. H2O goes to OH minus. That means that must have lost. So this is our base. This is our acid. Let's look here. NH4 plus becomes NH3. Well, looks like I've lost a proton, so that must donate to this one. So this is our acid, this is our base. Now, if you are in the regular college prep, you can stop watching because I have something for the honors kids to talk about, which is conjugate acid-base pairs. Or you could just continue listening because it's interesting. So for the conjugate acid-base pairs, really all you do is you pair up the acid on one side with the base on the other. So I'm going to get rid of this stuff right now so that we can do conjugate acid-base pairs. The only difference between the base pairs, acid-base pairs, is a proton. So the acid on one side and the base on the other. H2O, OH minus. Those are a conjugate acid-base pair. H2O and H3O plus hydronium, that's a conjugate acid-base pair. Acid on one side, base on the other, base on one side, acid on the other. Notice the only difference between them is a proton. Acid on one side, base on the other, base on one side, acid on the other, base acid, acid base, base acid, acid base. So those are the conjugate pairs. All right, hope this helped. Take care.